Hello, everyone. My name is Pfeifer, and I'm very grateful to be presenting today. I wouldn't be here without the LatinX and AI mentorship program, so many thanks for that program and to the community of all the support and opportunity. Today, I'm presenting automatic detection and classification of tick-borne skin lesions using deep learning. Around the globe, ticks are the culprit of transmitting a variety of bacterial, parasitic, and viral diseases. The incidence of tick-borne diseases like Lyme disease, tick-borne encephalitis, and rickettsiosis has drastically increased within the last decade. As a result, more efforts in improving lesion identification approaches and diagnostics for tick-borne diseases has been deemed critical by the medical community, especially in preventing serious long-term complications for people who suffer from these diseases. The medical community is working to apply deep learning in detecting and classifying skin manifestations like melanoma and skin burns. Our paper seeks to emulate a similar approach in detecting and classifying tick-borne skin lesions. We took a three-class classification approach of detecting tick bites, specifically erythema migrans, also known as the bullseye rash, a mosquito bite or clusters of mosquito bites for the confuser pathology, and healthy skin. Our model was trained using stochastic gradient descent, where the learning rate was set to minimize the training loss, resulting in most cases to a learning rate close to 10 neg3. The optimizer is Atom with weight decay. Our study ran a convolutional neural network across 4 different architectures: ResNet34, ResNet50, PGG19, and DenseNet121. The reason for this was to determine if each architecture presented similar rates of accuracy in detecting these skin lesions. Our contribution is the data set with varied queries that result in less biased skin colors. We expanded our image database by performing search queries in 7 different languages from geographies abroad that have a high number of tick-borne diseases: English, Spanish, French, German, Portuguese, Mandarin, and Russian. The search queries used for each class, if you recall, are tick bite, mosquito bite, and healthy skin. We decided to keep our search queries phrase simple in the initial phases, as we wanted to see what the results for each language were. More complex queries like healthy skin plus a specific body part, erythema migrans, or bullseye rash will be used in the next step of research as we refine and expand the model in the next phase of our research. The key performance metric in the study was accuracy in demonstrating the number of predictions our model correctly identified as tick bite, mosquito bite, or healthy skin. Our model obtained the best accuracy of 80.72 trained on DenseNet121 architecture. Our study generated promising results. The incorporation of using diverse approaches to gather data, such as our use of queries in multiple languages, exhibited a step in the right direction towards producing less bias in the image results. For instance, the search queries in Portuguese and Spanish for tick bite and mosquito bite resulted in images on darker skin tones, while the search query for healthy skin in English included more image results with darker skin tones as well. The accuracy rates exhibit room for improvement before being deployed into a medical use environment. The results of our model are a great start. We plan to make our data set public, and as we aim for results to encourage further research in the space of skin lesion detection for tick-borne disease diagnostics. And on a final note, here are the references used in the presentation. For more details, please visit us at our poster in the virtual poster session. Thank you so much for your attention.